want to form an octet structure with chlorine, is we prefer to lose this valency electron and give it to what? Chlorine. By what? By transferring the electron, this valency electron, to what? To chlorine. So when it's transferring the valency, this one valency electron, it will form a uniposity, which is what? Sodium positive. Why? Yes. Why this one will? Yes. Where is the? Why this one? After accepting the valency electron from sodium, it will come chlorine ion. Let's draw the electronic dot representation for the formation of what? Sodium chloride. See, this is the structure, electronic structure for sodium. This one is 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 8. Remain 1, Abi. This one is what? Sodium atom. This one is sodium atom. Why reacting with what? Chlorine atom, which is what? So this is chlorine atom. Therefore, when they want to form a stable structure, they what? They will transfer this one. We prefer to lose this electron and transfer it to what? Towards the what? Chlorine atom. So in the process of transferring, it will become sodium ion. Sodium positive ion. 1, 2, 1, 2, 1, 2, 1, 2. Become sodium ion. Why this one too? It will become 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Chlorine ion. So this one is before reaction. Why this one is what? After reaction. So this type of bonding is known as what? Electrovalent bonding. Do you hear me? Because of the transfer of electron from metal atom to what? Non-metal atom. So this is the chemical reaction for the action. It will be Na plus Cl give you Na plus Cl minus. So let's look at another example. Let's talk about the formation of calcium oxide, which is CaO, calcium oxide. What is the element configuration of calcium? The atomic number for calcium. Calcium 20. Thank you. 20. Calcium is what? 20. What about oxygen? It's not 16. 8. Oxygen is what? 8. So we want to write it 2, 8, 8, 2. Right? This one is what? 2, 6. You know this one is a metal. This one is what? No metal. So this one we prefer to lose the 2 electrons in its valency shell to what? To oxygen. So that they can be what? They can maintain they can obtain their stable octet configuration. So this is the electronic dot for this one too. Oxygen. Oxygen atom. Calcium atom. To give you So this one is calcium 2 ion. You know, it has lost two of its electron. Abi, why this one will be oxygen? Oxygen atom. So this is the reaction. Ca loses 2 electrons to give you what? Calcium 2 plus. Why oxygen plus 2 electrons give us O2 minus. So Ca plus oxygen will give us what? Will give us calcium 2 plus and oxygen 2 minus. So this one too is an example of what? Electrovalent bonding. Do you now understand? Do you now understand? So let me recap. Electrovalent bond is what? Is the bonding formula that involves the transfer of electron from a metal to a non-metal, or electropositive metal to what? Electronegative non-metal, or it may be an electron donor towards what? An electron acceptor. Why the bond? Why the bonding? So that they can able to what? To attain their stable octet structure. So it will involve what? The metal will lose maybe 1 or 2 or 3 of its electrons. It prefers to lose it. Why the non-metal? They will prefer to what? To accept the electron. That's all about electrovalent bonding. Do you understand? Do you understand? I give you some work now. Okay, let's talk about properties of electrovalent and ionic bond. Electrovalent or ionic bonding formation. 1, they are solid at room temperature. For example, that sodium chloride crystals that we talked about, that solid crystals you saw about, is an example of formation of what? Between sodium and chlorine. Abi? Yes, form salt is an example of what? Electrovalent bonding. So they are usually solid at room temperature. They consist of aggregate of oppositely charged ions. You know, this one, it contains what? Positive ion. Why this one contains what? Negative ion. But in equal amounts. Do you hear me? Yes. They have high melting and boiling points. They usually possess high melting and boiling points. And they are also good conductor of heat and electricity. So those are the properties of ionic or electrovalent bonding. So let's talk about covalent bonding. Covalent bonding. This type of bonding, it involves the sharing of electron. It involves the sharing of electron. A lone pair of electrons involves the sharing, not transferring, like what? Like the electrovalent bond. So a covalent bond consists of a pair of electrons. A pair of electrons is shared among the what? Among the 2 atoms involved. Electron, a lone pair of electrons will be shared among the what? The atoms involved. So sharing of electrons occurs between atoms of comparable electronegativities and atoms of the same element. Usually involve what? Atoms of the same elements. So a shared pair of electron equivalent bond is always represented by an horizontal line. Horizontal line. This arrow. Usually it shows what? Covalent, the sign for covalent bonding that exists between the 2 atoms. So, for example, hydrogen gas. Hydrogen gas involves the combination of 2 hydrogen atoms. Do you hear me? Hydrogen atom and an hydrogen atom will give you what? Hydrogen gas. So this one is known as what? This one is what are covalent bonding. You see this sign is known as what? Covalent bonding. Oxygen and oxygen. We give you oxygen gas. So this is oxygen atom and oxygen atom will give you oxygen gas. Chlorine atom and chlorine atom will give you what? Chlorine gas. So it means that covalent bond exists between the two atoms of the same element. So let me give you an example of the formation of hydrogen molecules. The formation of these hydrogen molecules using electronic dot representation. What is the electronic configuration of hydrogen? 1. Thank you. 1. Abi? 1. So if you want to draw the electronic structure, it will be like this. 1. You know it's only one electron, Abi? Combine with another electron, another hydrogen atom. This one is hydrogen, Abi? Hydrogen. So they will now form hydrogen 0 and 0. So this one is hydrogen molecules. So you can see that it involves what? The two elements, Abi? Yes. They share what? Electron. They share lone pairs of what? Electron. So this one is an example of what? Covalent bonding. Are you hearing me? Yes. Let me give you another example. Formation of chlorine molecules too. Chlorine. What is the configuration of chlorine? The atomic number of chlorine. 17, right? 17. So let's draw the electronic shell for chlorine. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 1, 2, 1, 2, 1, 2. So combine with another chlorine atom. So the product will be so this is formation of what? Chlorine molecule or chlorine gas. You can see this one also involves what? The sharing of what? A lone pair of what? Electrons. So these lone pair were being contributed by both the atoms involved. Do you hear me? Yes. So let's talk about the properties of covalent bonding. They have low melting and boiling points. You know, a covalent bond has what? High melting point, melting and boiling point. But this one, they have what? Low melting and boiling point. 2, they consist of molecules with definite shape. They consist of molecules with definite shape. They are usually gases. You know, chlorine, they are usually gases. Hydrogen formation, hydrogen gas formation, right? They are always gases. They are volatile gases. So because they are volatile gases, they are not bound by what? Strong electrostatic force. Remember the characteristics of gases. Remember characteristics of gases. You can remember it now. The molecules, they are always far apart, Abi. So they are not held together by what? Strong electrostatic force. So those are the what? Characteristics of what? Covalent bond. And they readily dissolve in non-polar organic solvent like benzene. They can dissolve in benzene, but they cannot dissolve in water. Do you hear me? Because water is what? A polar solvent. And they consist of molecules with definite shape. So those are the characteristics of covalent bonding. So we are now through for today with today's lesson. Is there any question? The hydrogen bond formation, this one, right? This one in the middle. This one, the dot. It's not what? It does not show here, Abby. You can put it there too now. It's just a diagram representation. Do you hear me? Remember that the atomic structure, we have the nucleus. We have the nucleus surrounded by what? Electron. Abby? So this one is this is the nucleus. This is the nucleus for this hydrogen atom. Another question.
The property, part of the property.
Yes.
Why did you add the can they also conduct electricity?
They cannot. Covalent bond cannot conduct electricity and heat. Are you hearing me? It's also the part of the properties of covalent compounds. Do you hear me?
Yeah.
So that's all for today. Let me give you an assignment. Right. Using electron dot representation. Using electron dot representation. Using electron dot representation. Show the formation of magnesium oxide. The formation of magnesium oxide and oxygen gas. The formation of magnesium oxide and oxygen gas. Oxygen gas or oxygen molecules. The formation of magnesium oxide and oxygen molecules. So tomorrow we are going to talk about coordinate, covalent, or dative bonding. So you now write your